Hello everybody, and welcome back to another quiz tutorial. So in this quiz tutorial, we're going to be covering quiz number 12, which involves embedding objects on R3. And I guarantee right now, I'll just say it outright, you guys will hate this one the most. I almost guarantee that you guys will not be a fan of this quiz. The reason why is it's very conceptual, I don't even know the word to describe it. It's one of those things that I find students either get it or they don't get it. So that's what took a little bit longer for me to prepare this video. Is I was trying to think, okay, well, for the students that don't get it, how can I explain this to them, or at least present a method to help them help them understand? So as you guys will see, normally I like to cover the theory. Well, there's going to be no theory for this topic because again, this is something that you guys will either hopefully understand or you probably will not understand. So we're just going to go right into the examples. And I think that once we do all the examples in this quiz, you guys will definitely have a better understanding of what to expect and what exactly this means, as well as I'm going to tell you any tricks that I have encountered throughout the examples. So there has been a little bit of tricks, not a lot, but hopefully it can help. So with that being said, let's jump right into the quiz. All right, guys, so question 1 of the quiz says, sketch and describe the geometric objects described by the following mathematical sets. So in this question, we're going to be given a bunch of ugly looking math equations, and we're going to have to figure out, okay, what does this object represent? Now, I have found that there are a couple little tricks in this to kind of guide you on the right path, the right direction, but some of it's just going to be straight up intuition. So we're going to go through that, and hopefully it can be a little bit more, make more sense, I guess would be the words I'm trying to say. All right, so if we look at the first mathematical set, we'll see that we have a vector in R3, which is expected, and the vector x is composed of 3 different things: x1, x2, and x3. And this is going to be the first kind of hint or constant that I've seen throughout these. For given 3 different parameters, in this case we have x1, x2, and x3. So 3 different parameters, this is going to be a 3D object. So I'm just going to write that down on the side so we should know, all right, from this we should expect a 3D object. So as such. So now you say, okay, Clayton, well, it's going to be a 3D object, has 3 parameters. How exactly do we find this 3D object? So if I were to look at this, I can kind of say, okay, this is going to be a cube. And that's just based on my intuition. And this is where I say, if some of the students get it, they get it. And they understand, oh, this is a piece of cake. Now, for the students that don't get it, this is an absolute nightmare. So I'm trying to figure out a way, how can I find this object if I can't illustrate anything in 3D? And the best way I can describe it is coordinate points. So basically, we're going to have this. I'm going to try and keep this in frame. X is going to be equal to x1, x2, x3. So I'm just going to write them in lowercase because it doesn't really matter. So it's going to be equal to x1, x2, and x3. And these are coordinate points in this coordinate system. And what we know is that all 3 of those values can range between 0 to 1. So 0 to 1, just like that. So if you guys really want and you guys don't really know what else to do, what I do is I just sub in coordinate points. And which ones do I sub in? Well, I look at the extreme values, the minimum values and the extreme values. So if I were to look at the minimum value per se, well, that's going to be when all 3 of those values are equal to 0. So x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0. And if I think about that, well, that'd give me the coordinate point 0, 0, 0. So what I do is I come to my diagram and say, okay, I got a coordinate point right here, 0, 0, 0. Not bad. And then I say, okay, well, what happens if I change one of those coordinate points to the extreme end of things? So let's say I take x1 as equal to 1, but then I keep x2 and x3 equal to 0. Well, then I'm given the coordinate point 1, 0, 0. So I come to my diagram and say, okay, I have the coordinate point 1, 0, 0. And then I can do the same thing for x2. So I'm going to have x1 and x3 equal to 0. And I'm saying, okay, well, x2 is now my extreme point. So then I get the coordinate point 0, 1, 0. So I'm kind of just coming through and I'm just creating a bunch of coordinate points. Now, what happens if I take x1 and x2 as the extreme values? Meanwhile, x3 is equal to 0. Well, then I get the point 1, 1, 0. So I come over here and I say, okay, I have the point 1, 1, 0. And I say, oh, wait a second. This right here, this is going to be a plane. So if I look at this just how it is, and I expected that to go straight, but it didn't. All right, that's much better. If I look at this now, I can see that this is a plane so far. Remember, we haven't dealt really a lot with x3 yet. But right now it's a plane. A nice plane, and everything inside of it I can get. So let's say I wanted this point right here. which is 0.5, 0.5, and 0, well, that point is included in the set because 0.5 is within our range of 0 and 1. Now, if I wanted this point right here, we can see that this point is not included. Because let's say that that is x is equal to 1.5. Well, 1.5 is out of our range. So that point right there is not included. So far, if we were just looking at the xy plane, we have every point inside of this boundary so far. So something like that. So I'm going to erase this because it looks pretty ugly. And now if we look at what we did, we say, okay, well, so far I took x1, x2, as well as the combination of x1 and x2 to the absolute extremes. But what happens if I start including x3? So let's say that we take x3 to the extreme, but we leave x1 and x2 is equal to 0. Well, then we get the point 0, 0, 1, which is going to be on that E3 axis. And let's say that point is right there on that axis. And I can do the same thing as I did before, where I can start taking two of the points to the extreme and leaving one of them as 0. So let's say I take x1 and x3 to the extreme, but I leave x2 as 0. Well, that'll give me the point 1, 0, 1. And we're going to say that that point is right there because it's going to be one step in the E1 direction and then one step in the E3 direction. And then finally, we can carry this over into x2 and x3, where I take both of those as extremes and I leave x1 as 0. And then what I do if I do that is I get the point 0, 1, 1, which will be over here. And then finally, the final case that I want to kind of look at is when I take all three of these values to their absolute extremes. And if that's the case, well, then what's going to happen is I'm going to get the point 1, 1, 1. And it's kind of hard to tell because I haven't connected the dots yet, but that point will be somewhere right there. So as we see, by including that x3 from 0 to 1, I take my plane and I don't know, extrude would be the best word. Yeah, I'm going to go with extrude. I sound fancy today. All right, I extrude that plane into the E3 direction. And by doing that, I get something like this, where this turns in from a plane, or I guess a square, all the way to a cube. And oh, yeah, this is looking actually pretty good. The iPad's saving me with the nice straight lines. So as we can see, this turns into a cube because we extrude that plane by the boundaries of our x3. So if we look at the top, remember, we can't just sketch the object. We have to provide some dimensions of it. Well, remember that we go from 0 to 1 in all of the cases. So I'm going to switch my colors. So I know that the length of the cube in the x1 direction is going to be equal to 1. I know the height of the cube in the x2 direction, like this. This will also be equal to 1. And finally, the length of the cube in the x3 direction, and I guess this would probably be the best place to try and include it. So the length of the cube in the x3 direction, this will also be equal to 1. So again, a lot of you guys will just look at this and go, oh, that's a cube, easy peasy, Clayton, don't waste my time. But then for those of you who might be struggling a bit, and for 3D objects, it's not too bad, but for some of the 2D planes, it's kind of shitty, I'm going to be honest with you guys. But for those, what I like to do is I just sub in points, and then I can easily start figuring out, okay, what exactly my object is. So let's move on to the next question, or the next part of question 1. Same scenario, except if we look at our mathematical set, we're missing that x3. So if we're looking at our vector, what it would be, and I'm just going to switch back to pink here, if you guys want to sub in coordinate points, in this case, we have the vector x1, x2, and then this one would always be 0. So this was actually something a little bit easier. And now here's kind of the other little trick referring to before. Remember before when I said that we have 3 parameters, x1, x2, x3, we're always going to have a 3D object. Now, the trick is if we're given 2 parameters, so in this case, we only have x1 and x2, we don't have an x3. This should be a plane. Well, Clayton, how does it become a plane? Oh, and I guess I'll write that down right here. So this one right here, we should be expecting a plane. Well, Clayton, how exactly does this turn into a plane? Well, let's take a look. And by doing that, we're going to sub in our coordinate points yet again. So we look at our domain here, and again, it goes from 0 all the way to 1. So I look at this and say, okay, well, if I take everything at the minimum value, x1 and x2 is 0, I have the point 0, 0, 0. So I'm going to come over here and say, okay, I have my point 0, 0, 0. Now, if I were to take x1 as the extreme and the rest are 0, then I get 1, 0, 0, so something right here. And if I were to take x2 as the extreme, 0, 1, 0, I get the point up here. And then I say, okay, well, if I want everything at the extreme, so x1 and x2 is equal to 1, then I get this point right here. So as we see, it's the same process as before, where we just created that plane. So if I were to connect the dots here, you guys can see that we have a nice plane in the E1, E2, I guess plane. it's parallel with that plane. Now, before what we said is, okay, well, we considered x1 and x2. Now we're going to consider x3 to give this object or this plane some depth. But if we look here, there is no x3. It's always equal to 0, and because of that, this will just remain a plane. So I'm going to just draw some straight lines. I should have done it in the other shape, but just trying to make it look a little bit nicer. This will just be a plane. And again, we should dimension it so we know exactly the dimensions of the plane. So if we look at I guess this would be the x2 direction. We know that it's going to have a height of 1 because we were given that maximum value of 1. And then looking across in the x1 direction, this will have a length of 1 as well. So just 1 and 1. So as you guys can see, these problems get a little bit trickier when it comes to a plane. Now this plane was nice and easy because it's just in the E1, E2 plane. However, once the planes start becoming angled, as you guys will see in question 2, it takes a little bit more to solve those questions. So now we're going to finish up question 1 with part C. And now C is a little bit different. If we look at C, we can see it's different right off the bat. So we're not given x1, x2, or x3. We're given t. Now, going back to the tricks, if we're ever given t instead of x1 and x2, or x1, x2, x3, we know that we're dealing with a line. Because if we look at t, it's just one parameter. So this right here, this is going to be a line. Right here. And this will be very easy to see because again, you guys say, hey, Clayton, I don't really see how you're getting a line from this. Well, let's look at the coordinate points. So in this case, we have x is equal to, and in this case, it's funny because they're all equal to each other. T, T, T. I come down here and I say, okay, my domain again is from 0 to 1. So if I were to look at the case where t is equal to 1, well, then my coordinate point would be 0, 0, 0. So something right here. If I were to look at the point 0.5, so that's still my domain, well, then my vector would be 0.5, 0.5, 0.5. So I'll take that as this point right here. And then finally, if I go to the extreme where t is equal to 1, well, then my vector or my coordinate point would be 1, 1, 1. So I'm going to get a point up here. I'm just trying to make this look as nice as possible. And as you guys will see, the line's going to look something like this. And this means absolutely nothing right now because it's very hard to see. So let me switch to my dotted lines and show you guys exactly how this line is supposed to look in 3D. So this line right here is actually going to drop down here, and it's going to have two components. The one is, of course, in the x direction. The other one's in the y direction. So I guess that actually doesn't look too bad. So if I were to dimension this, then this final coordinate point will be, oops, I forgot to switch back from the dotted line. All right, so let's get rid of this. All right, so if I were to dimension these dotted lines, and I'll come back up here so you guys can see a little bit better, we know that this is going to be 1. So this right here is going to be 1, because again, this is the maximum value. This way will also be 1. I guess I wasn't very specific. Along the x1 axis, this will also be 1. Oh, I'd love to see someone write an exam and say, oh, it's this way or that way, instead of actually referring to the proper things. And of course, this has a height. Oops, the iPad's not really cooperating with me right now. All right, come on. We got this. All right, perfect. And then we know the height of this point is going to be 1. So if you guys aren't like me, you guys just want the nice and easy way, I guess the better way would just to go the point 1, 1, 1. But I don't know. I'm a sucker for punishment. I always like making things harder than they appear to be. All right, so this is question 1. So what I find is that question 1 is easier than question 2. So if we're given the mathematical set, it's not as bad because we can start substituting in numbers, finding the maximum and minimum coordinate points, and starting to develop our shape that way. Now, if we look at question 2, it says, explicitly write the set, and I guess this is omega, that represents the following geometric objects. So this is the complete opposite before. Before we were given that omega, that set, and we were expected to write sketch the geometric objects. Now it's the opposite way, where we have the sketch and we want to find out what is our set. So I'm going to come down here and say, okay, well, this is going to be A. And we know that our set omega, I guess omega naught, is going to be equal to, and we go squiggle brackets, And we know that the vector is always going to be in R3 because we're always dealing with the E1, E2, and E3 axis. So what we're going to do to start is an element of R3. And this is just because we're dealing with the E1, E2, and E3 axis. But now it gets fun. Now we have to say, all right, well, our vector is going to be equal to, and here's the trick, or I guess not the trick. The first thing that we're going to want to do is look at, is this a 3D shape? Is this a 2D shape, or is this a line? And very clearly, we see that this right here is a cube. And you go, oh, a cube? Well, we actually kind of solved for a cube before, or I guess not a cube, but a rectangular cube. Call it whatever you want. But we already know that this is a 3D shape, so it's going to have x1, x2, and x3. And we know that we can represent this cubic shape using x1, x2, comma, and then x3. So just like that. And this is just right from before. So we're actually already know this if we did question 1 correctly. Well, hopefully we did question 1 correctly. But now here comes the tricky part of this, because before we were given that domain between 0 and 1. And if we look at the dimensions of this cube, they're all different. They got A, B, and C. So what we're going to do is we're going to have to define what each one of these is. So for x1, we know it starts at 0. It's greater than equal to x1. So we're saying that x1 is between 0, and we have to look at the diagram. So remember that x1 is related to this E1 axis. So what I'm doing is I'm looking for that horizontal component. So when I look up top here, I see that A is that horizontal component. So we're going to say that 0 is greater or equal to x1, which is greater or equal than A. So there's my first kind of domain. I come down here, I do the second one. Again, we're going 0 is greater than equal or less than or equal to x2, which is less than or equal to. So now we got to go back to the diagram and say, okay, now I'm looking at x2, which is this E2 vertical axis. Well, which dimension is vertical? Well, that's over here. That's B over here. So what I'm going to do is I'm going to come down here and say, okay, 0 is greater or less than or equal to x2, which is less than or equal to B. And finally, just by the process elimination, you guys can say 0 less than or equal to x3, which is less than or equal to C. And if you guys look up top, it's not hard to see that the E3 axis here, so this E3 axis, it's aligned with dimension C. So again, not the hardest example, especially if you guys did question A right. If you guys did question A right, you come down here and just copy what question A is. The only difference is the dimensions of the cube are different. So we're just going to have to define the main to express the new dimensions of that cube. So that was a 3D shape. Now let's go down here and get to something a little bit more challenging, and that's a 2D plane. And this is where students will have actually, I believe, the most trouble is this question right here, a 2D plane. So if what I'm going to do really quick is I'm just going to write those little tricks. So we know that this is a plane right here. And in this case, it's going to be a function of x1 and x2. So just x1 and x2. We don't need x3 in this case, as you guys will see, even though it looks like there's some x3 components. So what I'm going to do is I'm going to come down here and I'm going to start writing my mathematical set. So I'm going to say omega naught is equal to, and I'm going to do my fancy squiggle brackets because I'm feeling real fancy today. I'm going to say that our vector x is an element of R3. So again, this is just how we start since we're dealing with the E1, E2, and E3 axis. And I say, okay, x is going to be equal to, and this is where it gets tricky. So the first one is, how does it vary along E1? And if we look at our E1 components, they're just straight. They're all nice and straight. So from here we can say, all right, this is just going to be x1. And I'm going to go comma, and I'm going to say, okay, well now we have x2. And if we see, we can go from 0 all the way down, or I guess I'm going to scroll up a bit. We can see that we can go from 0 here all the way down here. So we can do x2 right here. So I'm just going to put x2. And I know that's kind of hard to see, but as you guys will see, there's actually different solutions we can do. So what I'm going to do actually is just, this is probably the better way to explain it. I'm just going to say x2 is equal to x2. Okay? I'm going to say that x2 is equal to x2, but as we can see, x2 is actually a function of x3 and vice versa. Because if I were to draw this, what I'm doing is I'm going to draw the coordinate system here. And what I'm going to say is this one is E3, and this one over here is going to be E2. And what I'm going to do is I'm going to draw this line here, this diagonal line within these two. And what you guys will see is it's going to look something, and I'll change the color to really make it pop. It's going to look something like this. So as we can see, that line there is a function of E2 and E3. So if I wanted to, I can just say that E3, X3 is equal to X3, and then derive the function X2 in terms of X3. Because if we look at this here, we know that it goes from 1 all the way to 1 right here. So we can do many different things. This is just a simple y is equal to mx plus b. But what I find out from this is that x3 is going to be equal to, I'm just trying to look at it, 1 minus x2. 1 minus x2. So what I could do is I come down here in my original vector. What I normally would have done is I'd go x3. But I say, okay, I actually have x3 as a function of x2. So what I can do is I could say, okay, well, instead of x3, I'm going to write this as a function of x2. In this case, it's 1 minus x2. And I can close this and say this is good. So see how a plane is related to each other? It's basically because we can express one variable in terms of the other. Now, if I wanted to, if I really wanted to, I could have said, no, I don't want it this way. I could have said this one as something x3 and then comma x3. So that's what I could have done. Instead, I want to keep it nice and easy because who wants to go x1 and x3? No, nobody does. Everyone wants x1 and x2. So if that's the case, I'm just going to say, okay, well, I'm going to keep, I'm going to erase this here. I'm going to say x2 and then comma 1 minus x2. So this vector right here, this is the one that'll trick most of the people. And I know that even explaining this, it's pretty difficult. I hope you guys can kind of understand. I guarantee I'll have a lot of questions about this afterwards. The good news for you guys, this very rarely appears on a midterm. It might just be one question. But this knowledge here of embedment, you guys don't really need to know it moving forward at all. So even though it's a very abstract concept, don't worry too much. It doesn't really appear later on. So what we're going to have to do now is we're just going to define the domains. And for x1 and x2, they have the same domains. What I can do is go for every I, and then the thing I can say 0 is less than or equal to xi, which is less than or equal to 1. Because if we look at our drawing, everything was between 0 and 1. And I forgot, I used the wrong type of bracket. If we look up here, all those dimensions are equal to 1. So this is the one that'll confuse the most. Confuse almost everybody. If you guys can get this, you guys are experts. Don't worry about it too much. All right, so I'm going to come down here, and this is going to be the last one. So remember, if we're given a line here, in this case, this is just a line, we use t. So what I'm going to do is I'm going to come down here and say, all right, oops, didn't mean to zoom in there, guys. All right, well, this is going to be a long quiz video. It's so hard to explain these abstract things. So I'm going to write my omega is equal to x, which is an element of R3. And I'm going to put my nice vertical line. I'm going to say x is equal to, and maybe this will help explain the previous one a little better. So what I can do is I can say, all right, x is a function of x1 and x2. So what I could do is I can say, let's just go x and y. X, y, and we see that there's no E3 component right off the bat. So what I can do is I can say, this is equal to x, y, and 0. So it's a function of x, it's a function of y, and it's equal to 0. But instead, remember, a line is only in terms of one thing. And that, in this case, we use a relationship. So we know that y is actually equal to x squared. So I can come down here, erase the y, and say that this is actually equal to x squared. And we say, okay, well, now we have everything in terms of one variable. Well, now we're just going to modify it just a little bit to make it actually in terms of t. Because remember, we express those nice lines as a function of t. So I'm doing is I'm taking away x and just replacing it with t. So we got t and t squared. And then that's it. That's all we have to do for the line. We come down here and then we have to say, okay, well, the domain for this is 0 is less than or equal to t. And if we look up here, it's between 0 and 1. So we go less than or equal to 1. And that's it. And I say that's it, but I know that, again, this is either going to make you very happy because it's an easy question, or this is going to want to make you pull your hair out. So hopefully this wasn't too bad. I really hope I could made it just a little bit more clear. I don't expect to provide full clarity with this one. This This is a terrible type of question. I myself don't like them. They can be banished to the shadow realm for all I care. But yeah, I hope I helped you guys at least a little bit. So for those of you guys who made it all the way to the end of this video, I know it was a little bit longer and I'm sorry about that. Just really wanted to try and explain. Thank you guys so much for listening. I really appreciate it. I really appreciate all the support of the videos and everything that you guys have said about the videos. It means a lot to me. So yes, thank you guys so much for listening. I will see you guys in quiz number 13.